Okay, so I continue from where we ended the other day, and this is question 2. Find the resultant of the forces. And then these are the forces. We have force 1 is giving us 6 Newton with a bearing of 60 degrees, and force 2 is giving us 12 Newton, a bearing of 150 degrees. So one thing that we need to know here is that all coplanar forces, when you are asked for the resultant is equal to the sum, the vector sum of the forces. So resultant is equal to the vector sum of the forces. So if you are asked for the resultant, you mean that you have to sum all the forces together before you can get the resultant. So let's try and then arrange this into their component form. And from what we did first, you know that we can simply group this one to the x and y component. So to get our x component, we use the 6 and then bring sine the angle. And then to get our x component, our y component, 6 cos the angle. So when you point this one in your calculator, you get something like this. 6 times 0.866, and then 6 times 0.5, which is equal to 5.196, and then 3. We can also resolve our F2. That's force 2 to be equal to, we use the same principle, saying our x component is going to be 12 sine 150 degrees, and then our y is going to be 12 cos 150 degrees. So using the calculator, punching this one in the calculator, add 12 times 0.5, and then 12 times negative 0.866, which finally gives 6 minus 10.392, like this. And we know that the resolution of forces, which is R, is the sum of the forces F1 and F2. We now know that F1 is now equal to, F1 is finally equal to 5.1696, then 3. My F2 is equal to 6 minus 10.392. The resolution of force here, R, should equal to F1 plus F2. So we have this way. My F1 is 5.1963 plus my F2, 10.392, this way. So putting everything together, we have our R to be equal to 11.196 and minus 7.392. Okay, so our S component is 11.196 and our Y component is minus 7. So we use the Cartesian plane to locate our X and our Y. Our y is negative and our x positive, meaning it is in the fourth quadrant. So our force or our resultant, which is r, is here. And then we have our x, which is 11.1.196, so say on the x. And then you can have our y here, and our y is given as 7.392. We write 7 point and not negative 7 point because the negative 7.392 help us to locate the quadrant where the force will be. So now we have our s and our y. So what is the angle that the force make with the horizontal? That is what we call theta. So we try to find the angle the force make with the horizontal. So we use tan theta, opposite over adjacent. So opposite is 7.392 and adjacent is 11.196. And by using our calculator to find the tan inverse of theta, we say theta is equal to tan inverse of 7.392 on 11.196, and then the angle finally came 33.4 degrees. So 33.4 degrees, but that is not a bearing. So if we take 33.4 degrees, that's not correct. Because for bearing, we measure from north in a clockwise direction. So for us to get the bearing, the right bearing of this particular arrow, then 90 plus theta should give us that answer. And now theta is what? 33.4. So we say that the bearing is now equal to 90. Because 90 is here, you add it to this theta before you get a bearing. So 90 plus 33.4, which gives us 123.4 degrees. So we say that the bearing of R is equal to 123.4 degrees. Okay. So let's talk about finding the magnitude of the resultant. So you can resolve this one, this form. X is there, have our y, have our resultant here, r. And then we have, make an angle of 90 degrees here, 7.392, and then 11.196. So by using Pythagoras theorem, we say that the resultant square is equal to x squared plus y squared. So my r squared is equal to, my x is 11.196 squared plus 7.392 squared. So let's square root this one. Square root the whole of this one. My r finally equals to 179.99, which is 13.42 Newton. So in direction form, so if you want to write the magnitude or resultant in the direction form, we say that in the direction form have arrow being the resultant, and then the magnitude, which is 13.42 n, and then the angle that it made, which is 123.42 degrees. So this is how this question can be solved.